Okay, stay with me here. If you gathered together and weigh all the spiders in the world, you would get 250 million tons of arachnids. Wait. Before you run away, for comparison, the Titanic's weight was 52,000 tons, and the Great Pyramid of Giza is as heavy as 6.5 million tons. Well, you're right, that doesn't make me feel better either. But on we go. The biggest spider people know about is the South American Goliath bird eater. Yeah. This brown, furry, puppy-sized arachnid usually has a foot-long leg span. Its body is the size of a large fist, and its weight is more than 6 ounces. When the creature's moving, it makes bizarre, eerie sounds. They're the clicking of the spider's feet. They have hardened tips that hit the ground like a horse's hooves, just not as loud. If you see this imposing creature in the rainforest and come close to it, you might notice it rubbing its hind legs against its belly. How cute, that would be your first thought. But then you'd scream in pain. This spider protects itself by sending out clouds of hairs that have microscopic barbs on them. If they got in your eyes and nose, they'd be super painful and itchy. These hairs would also stay there for hours or even days. Now, that sounds extremely unsettling. But imagine what our planet would look like if spiders were the size of jeeps. The world occupied by giant arachnids is a dark and gloomy place. It's also dangerous. You can't let your guard down even for a second. Your enemy is lightning fast, hungry, and cunning. Normal-sized spiders eat 880 tons of insects each year. But in your world, huge monsters need much more food to live. Spiders roam the planet, gulping down pretty much any life form they see. If people gave up and didn't fight them, Earth would turn into a lifeless, barren land within a year. Up to 6% of people all over the globe have arachnophobia, extreme fear of spiders. But if these creatures were that much larger, this number would be way bigger, you think? Picture a creature more than 5 feet tall with a leg span of 14 feet. The spider's covered in coarse, thick hair, which makes the animal look disgusting. Its body is divided into 2 parts, separated in the middle by a slim waist. A set of massive jaws, terrifyingly long and sharp fangs, and 8 spherical eyes, as huge as basketballs. But the creepiest of them all? Spiders without eyes. They live in caves and other dark places. If you meet such a specimen, your reaction won't be fast enough to escape. These creatures compensate for their lack of vision by feeling vibrations. They also have an astonishing sense of smell. Terrified of spiders, people constantly invent new ways to get rid of them. Being caught by a creature several times your size is everyone's biggest nightmare. One of the scariest things about spiders is the way they deal with insects they catch. Most of these predators don't eat their prey whole. At first, it gets cocooned in silk and injected with the spider's digestive fluid. It paralyzes the prey and makes its insides liquid. That's not good. Then the creature pulls everything edible into its stomach through the hairs covering its mouth and pincer-like jaws. In other words, once a monster spider gets you, there's no way to escape. Oh, and don't forget about horrifying spider webs. Who hasn't ended up with their face covered with sticky threads at least once in your life? In your new reality, though, spotting a web in time means getting a chance to survive. Even regular-sized spiders can create webs that cover trees and houses and stretch over rivers for 80 feet. That's why if a new world creature chooses your house as its new home, it's easier and safer to move out as fast as you can. People have found a way to deal with giant spider webs, but how they do it depends on which species has created it. If the web was produced by a spider that's more active at night, people destroy them with help of UV lamps that replace sunlight. The webs made by spiders living in dry areas are afraid of liquid. Those from humid environments don't like getting dry, and so on. Another problem. One day you may come home and discover a huge monster, or 50 of them, living in your basement. Okay, admittedly, you're likely to spot these creatures before they reach any impressive size. They'll be too loud to go unnoticed. Spiders don't give birth to their babies. They create egg sacs that can contain hundreds of eggs. If such a sack somehow ends up in your home, you've got a problem on your hands. In a couple of weeks, those eggs hatch into baby spiders. After that, it can take from 2 weeks to 1 year for the babies to reach their full size. Oh, by the way, people have figured out how to use spider webs. The silk they're made of is very light. If it was a tiny regular spider, a strand of its silk long enough to circle Earth would weigh a mere 18 ounces. In a spider, dozens of times larger. Silk threads weigh more, but they're also much stronger. They can withstand extreme temperatures from -40 to 430 degrees Fahrenheit. People know how to collect spider silk. They use this material to make ultra-strong ropes. Almost all fabrics in the world are made from spider's threads. Wear-resistant and lightweight clothing, seat belts and parachutes, bottles and cups, surgical threads and bandages, rust-free panels on cars and boats, artificial ligaments and tendons, all thanks to spiders. But probably the best thing about silk, it's biodegradable. Earth has become a much cleaner place since people started using this material in production. Along with using spider silk threads, people also gather the glue covering the webs. It's a unique substance. It stays wet in the open air and is still sticky after having trapped several insects. Up close, this glue looks like tiny beads on a string, or rather golf-sized balls on the rope if we're talking about car-sized arachnids. They produce much stickier glue than good old regular-sized spiders. That's why, in most cases, it replaces hammers and nails. All kinds of vehicles and vessels are built with the use of spider glue. The only drawback of this sticky substance, you have to be extra careful while gathering it. Once you get trapped, it's a tricky feat to escape. That's why people go glue hunting in large groups. But even if you get into a spider web by accident, there's a chance to survive if you're fast enough. Moths and butterflies have a special layer of scales on their wings. They can shed this layer if they get caught. Use this trick, take off your clothes and run for your life. But how come spiders don't get tangled in their own webs? These arachnids can spin sticky and non-sticky silk. They avoid walking on the sticky parts of their webs. Plus, they have special movable claws on their feet. These claws grip and let go of the threads when they're moving. Also, spiders' feet are covered with thousands of hairs. When they walk, these hairs create countless points of contact between the animal and the surface. That's why you can see gigantic spiders lounging on rooftops or climbing skyscrapers. By the way, when the terrifying creatures do move, they do it at breakneck speed. The giant house spider is one of the fastest spider species in our world. It can move at a speed of almost 2 feet per second. That's more than a mile per hour. But creatures as large as a Jeep can speed up to 50+ miles per hour. In other words, you wouldn't be able to escape from them by driving away. In the giant spider world, people have to install tons of artificial lights. Dense, thick spider webs are everywhere. They appear throughout the night and cover large areas, making days dim. Trees and not-so-sturdy constructions often collapse under the weight of spider silk. Luckily, it's just an imaginary world. Spiders can't grow to be as large as a car. Long story short, their hormones prevent these creatures from becoming larger than they're supposed to be. Whew! When you think about it, spiders were one of nature's first true engineers. They make the toughest casters you can find on our planet. The silk spiders use to build webs is stronger than steel. They trap their prey in that web. They use it to dangle from the ceilings in our homes and haunt our dreams too. Their silk is extremely stretchy. Considering how stretchy the silk is, plus the amount of force you need to use to break it, that combination shows the silk is so strong, it's able to take 3 times as much energy as Kevlar before it breaks. Now, Kevlar is a synthetic material used for tires and some other rubber products like cut-resistant gloves or flame and blast barriers. It's also a material used for sports gear. For example, it's the thing in your running shoes that helps you maximize your energy output. With Kevlar, boats are more tolerant of damage and lighter. It's extremely strong, 5 times stronger than steel, and lightweight at the same time. Dragline silk is an especially strong kind of spider silk. A drag line connects the spider to its web. It's something like a safety line in case a spider falls, and it needs to be strong enough to support the weight of the spider. A single strand consists of protein molecules, and they're aligned together really tightly. Each strand of spider silk is 1,000 times thinner than human hair. That's why you can break it so easily, even though it's really strong. But each strand is still stronger than many types of steel. You just have to get steel equally thin to truly compare it. Scientists believe that if we could make dragline silk, for instance, as thick as a pencil and 18.6 miles long, we would have material so strong we could stop a jetliner in the middle of the flight. But the passengers probably wouldn't like it. When it's windy outside and a wind or even just a light breeze catches the spider's sturdy dragline, it catches air and turns into some kind of an open parachute. That's when the adventure starts for a spider. Its dragline bends and stretches further. That way it can send the spider to fly very far away and it won't break. And this way, spiders can really fly away hundreds of miles. Since spider silk is so strong, it inspired researchers to come up with new material. It's known as something called elastomer, since it's elastic like rubber. This material has a structure just like a spider web, and that's what makes it durable and allows you to evenly distribute the stress you put on it without breaking it. Just like spider silk, it's both exceptionally tough and stiff. Stiff materials can take a lot of stress before you manage to deform them, whereas tough materials can absorb a lot of energy before you break them. For instance, glass is stiff but not tough. When it comes to commercial materials, it's mostly a trade-off. With higher stiffness comes lower toughness, and vice versa. The fact this new spider silk-inspired material is high in both of these features makes it even cooler. There are more extremely hard materials we're discovering or even inventing. For example, there's a new type of glass that's harder than even diamonds. Diamonds are generally the hardest of all natural materials. But now, scientists have made a new type of carbon they named AM3. It's now the strongest and hardest amorphous material we know about. Amorphous means material doesn't really have apparent organization or shape. For example, rubber, glass, wax, and plastics. Diamonds are that strong and durable thanks to their extremely regular structure. You'd think this new material that's even stronger than that has a structure like a diamond too, but it's actually more similar to glass. You may have heard some people believe that glass is a liquid. It's not, but we really can't put it in the category of solid materials either. It's a peculiar amorphous material. So the molecules aren't as disorganized as in a liquid, but they're not in strict order as you'd see in a solid. AM3 conducts electricity well, but just in some cases. That means we could potentially use it to get, let's say, solar energy. This material would come in handy for bulletproof windows that are up to 100 times tougher than the technology we currently use. Mass production of this material will certainly be expensive. Plus, we'll have to wait for researchers to test it more. But this new yellow-tinted glass is definitely a material we might see a lot of sometime in the future. The next one is wurtzite boron nitride. It's quite weird. It's harder than diamond. Some studies say 18% harder, which is a lot, and it's amorphous at the same time. But the craziest part is that it's extremely rare because it forms only during volcanic eruptions. Then we have Lonsdale-lite. Let's say there's a meteor full of carbon that contains a bit of graphite too. It goes through the Earth's atmosphere and eventually collides with our planet. You probably think a meteor that's falling toward us is extremely hot. In reality, only its outer layers become hot. The interior of this object remains cool throughout most of its journey toward our planet. When this meteorite hits the surface of Earth, the pressure in its interior becomes insanely big. It's stronger than any other natural process that can affect the shape of graphite or some other material. Like if you squeeze it or try to shape it with whichever technology you'd want. you'd still don't get a force that's as strong as the pressure that occurs during this impact. Because of this, the graphite in that meteor compresses and now has a crystalline structure. It's not like a diamond, even better. It turns out to be 58% harder. But for now, graphite that's harder than diamond is just a scientific theory. Scientists do study some real examples of graphite and its different shapes, but they have only those that are not that pure. That means there are lots of other elements in these materials that make this material softer than diamonds. But if there was a special pure graphite meteorite heading towards our planet and striking the surface, it would, without any doubt, create material way harder than any diamond we have ever found. And how about dyneema? It's the strongest fiber in the world, 15 times stronger than steel. It's also nearly 40% stronger than aramid fibers. For example, Kevlar used for tires, the one we mentioned before. Dyneema is lighter than water, but is still great for things like ropes and towing lines for the shipping industry. It's a great material for nets for fishing and safety gloves in the metalworking field too. Now here's something called palladium microalloy glass. As we said before, there are two very important features all materials have. The first one is strength. That's how much force some material can withstand before you manage to deform it. The second one is toughness. This stands for how much energy you need to fracture or break it. Ceramics are mostly strong, but not very tough. Elastic materials, such as rubber, can hold a lot of energy, but you can deform them relatively easy, and they're not strong. And over a decade, researchers created a new glass with a combination of 5 elements that ended up as a material that's stronger than all types of steel. Yup, this glass will rather deform than break. This is actually the hardest material that doesn't include carbon. And meet Bucky paper. In the late 20th century, we discovered there's a specific form of carbon that, once again, is harder than diamonds. It's called carbon nanotubes. If we bind carbon into a different shape than diamond, we get a structure that's way more stable than any other we know about. And putting these carbon nanotubes together, you create Bucky paper, which is basically an incredibly strong but also very, very thin sheet. It holds just 10% of the weight of steel, but at the same time, it's hundreds of times stronger. I don't mean to bug you, but spider silk is one of the most durable natural materials on the planet. Kevlar, of which body armor is made, is weaker than the stuff spiders produce inside their bodies. It's hard to believe because if you've ever touched the spider web, you realize you can easily break it. That's because spiders secrete a very thin layer of silk. Most metals would break in no time as well at such thickness. The good news is that there are no huge spiders on our planet, which means you can't get stuck in their trap. The bad news is that if thousands of spiders with the strongest silk in the world join together and weave a single big web, well, you're in trouble. The most durable silk belongs to Darwin's bark spider. Its silk is twice as strong as that of other species. The spider is much smaller than most of its kin, but this doesn't prevent it from being one of the most formidable predators in the world. The area of its web reaches 30 square feet, and it's suspended over rivers on incredibly long lines. The female spider shoots a stream of silk, which is caught by winds above the moving waters and carried to the other bank, where it attaches itself to a tree or a bush. The distance could easily be over 80 feet. You can find this natural wonder only in the tropical jungles of Madagascar. Imagine that several hundred Darwin's bark spiders spun a thick web over a river. You're going downstream in a kayak at the same time. From a distance, you don't notice the huge trap, and when you finally do, it's too late. You get caught in the silk, the kayak goes out from under you. You hang in the air. Thousands of web strands vibrate and give the spiders a signal that their dinner is here. You don't have a dagger or a machete to cut yourself free. The first thing you need to do is save your strength and energy. The more you resist, the more entangled you get. The fact is that the spider's web is sticky. The more you move, the more glue gets on you, slowing down your movement. By the way, there is a group of the cribellate spiders whose web is completely dry, but the threads are surrounded by clouds of ultra-thin filth. If the prey begins to move, these clouds come together and become stronger, entangling the insect even harder. When insects get caught in a spider's web, spiders, especially small species, don't immediately run up to the prey. They are waiting for it to lose all strength to resist. After that, spiders carefully approach the dinner and spit out digestive liquid with venom, which means that the digestion process begins not inside but outside the spider. Then the hunter wraps the body of the insect with silk to form a cocoon, inside which the prey is digested. After that, the spider drinks back its digestive fluid with the food. The process can be repeated several times. Well, let's hear it for recycling. Now, back to you, stuck in a big web. You realize all these terrible events that are about to happen, and your brain begins to work as quickly as possible. From all sides, hundreds of small spiders are running towards you, looking forward to their meal. Your time's running out, but then a solution strikes you. You wriggle out of your clothes and fall into the river. Yeah, you're almost naked in the jungle of Madagascar, but it's much better than becoming a dinner for spiders. You're watching as the arachnids climb up on your clothes and wrap it in a cocoon. Now, about those piranhas. Just kidding. Some spiders use a strong venom that penetrates the insect's body and dissolves it from inside. But the worst fate awaits an insect that gets caught in the Philopponella vicina spider territory. These spiders don't have venom at all. When a small insect gets into their web, the hunter quickly runs up to the prey, twists it, pulls the silk out with its hind legs, and wraps the insect in it. The spider spends a lot of silk, up to 460 feet. That's twice the length of a passenger Boeing. The spider turns its prey 28,000 times during the wrapping. The insect is literally squeezed under such pressure. After this, the spider secretes digestive fluid inside this cocoon and, well, you get it. Yeah, dinner is served. The web serves not only as a trap for insects, it's the eyes and ears of spiders. Nearly all spiders have weak eyesight, despite having 6 or 8 eyes. We humans can immediately see if a little fly is caught in the web, but the spider doesn't know this. It touches the strands of the web with its 8 legs and feels for vibrations that tell it where the prey is or where the web is damaged. Also, the smallest silk vibrations tell the spider about the humidity of the air or the presence of wind. The spider can distinguish the slightest change in the structure of the web, like a musician who hears an instrument is out of tune or doesn't hit the right notes. I said nearly all spiders don't see well, because some species can see much better than humans. One of them is a jumping spider. Their vision allows them to see colors that people can't. But this spider is also interesting because it doesn't weave a web for hunting. It sits and waits for its prey. When a fly or beetle lands on a flower nearby, the jumping spider leaps at it and bites it with its sharp fangs. This small predator can jump up to 50 times the length of its body. It uses silk as an insurance cable to soften the fall, avoid falling on the ground, or return to the original position if it couldn't catch the prey. But you should not be afraid of them, because jumping spiders are actually cute, and many people even keep them at home as pets. Some species of spiders use silk to travel long distances. They shoot strands of it, like one famous superhero, and use them for climbing. Others use wind instead. Their silk is so light that the wind blows it away with the spider. You could say such spiders can fly. And then there are wolf spiders. They don't jump or weave. Instead, they run after their prey, making them the sprinters of the spider world. Unlike jumping spiders, wolves are bigger and look quite scary. When they catch up with their prey, they inject it with venom. But the worst thing is that these spiders have adapted to live in any conditions, from cold mountain peaks to hot deserts and rainforests. People who fear and hate spiders should remember that these creatures control the insect population. Without spiders, the number of insects will increase dramatically, and all agriculture will be threatened. Wheat, corn, vegetables, and fruit may disappear, resulting in a global food crisis. Remember this when you want to hit a spider with a slipper. There are about 45,000 known species of spiders that live all over the world. But some scientists believe there are twice as many species that we don't know anything about yet.
In 2008, NASA had an intriguing question. How do spiders construct their webs in zero gravity? Therefore, they sent 2 spiders to the International Space Station. The first spider was the main participant, while the second served as a backup in case the first one didn't survive. However, things didn't go according to plan. The backup spider managed to escape from its chamber and visited its companion, resulting in a bit of a mess. They built tangled webs that interfered with each other. As if that wasn't enough, the flies that were supposed to be food for the spiders started reproducing faster than anticipated. Their larvae escaped from their container and covered the front window of the chamber. Over time, the spiders were completely hidden behind the larvae. Although this initial experiment didn't go well, one of the researchers involved in planning the spider experiment was still curious. In 2011, she got another opportunity to repeat the same experiment. This time, she sought assistance from other researchers. They decided to send a different species of spider into space and prepared 4 spiders, 2 for the ISS and 2 for Earth, allowing for result comparison. The goal was to expose the spiders to varying gravity conditions and observe their behavior. However, another twist appeared in the story. Initially, they believed they had 4 female spiders, but it turned out that 2 of them were actually males. Determining the sex of young spiders can be tricky, but fortunately, one male had already been sent to space, while the other remained on Earth, enabling valuable data collection. The second experiment proved successful. The spiders were active. They built and dismantled webs, and even without the assistance of gravity, they spun new ones. 3 cameras captured thousands of pictures, showcasing their hard work on the webs. Interestingly, it seemed that spiders created significantly more symmetrical webs in space than on Earth. The center of the webs was closer to the middle, and surprisingly, the spiders didn't always position their heads downward as they typically do on Earth. However, one significant factor made all the difference: light. When the spiders on the ISS had a source of light, they weaved asymmetrical webs, similar to those found on our home planet. Light played a crucial role in orienting the spiders in space. The chamber's lamps were attached at the top. If the lights had been positioned differently, for example on the side, it would have been challenging to observe the effect of light on the symmetry of webs in zero gravity. When the lights were turned off, the spiders rested in random orientations within their webs. Yet with the lights on, they would orient themselves away from the light source, which meant downward. Hence, in the absence of gravity, light assisted them in orientation. This discovery was unexpected, because spiders can typically build their webs in the dark and capture prey effectively, even without light. Spider's web itself is such a cool thing wherever they are. It's like these creatures have small silk production factories inside them. Within their body, a thread is stored in the form of a highly concentrated liquid. And a regular garden spider can produce up to 7 different types of silk, each having a unique combination of proteins. Each type of silk has a different purpose. For example, one type of thread makes the web elastic, which means the web absorbs the impact when insects collide with it. Another type of silk makes the thread flexible and strong, so it's more difficult to break. Some proteins found in the silk protect it from harmful bacteria and fungi, allowing the web to last longer. They also keep the silk moist so it doesn't dry out. Wow. Imagine having a home where you don't have to buy anything extra to maintain it. Spider silk is lighter than cotton and incredibly thin, up to 1,000 times thinner than human hair. But it's also insanely strong. I mean, it must be, since that's what they rely on while living their everyday life. Whether they're preying on some wandering insect or trying to resist heavy rain and wind. But you wouldn't expect it to be stronger than steel, right? Of course, in reality, you don't come across steel that thin. But if you could find a piece with the same weight as spider silk, you'd see that it has similar strength when pulled or stretched. In fact, spider silk is 5 times stronger than steel of the same thickness. Spider silk is also super stretchy, able to stretch up to 4 times its original length without breaking. Plus, it remains strong even in freezing temperatures below -40 degrees F. The most common type of spider is the orb weaver. They're masters at building those webs you keep seeing in open areas. That's where they have a better chance to catch a tasty lunch. But since they choose such spots, their webs are more prone to damage. That's why these spiders have a fascinating habit. They often rebuild their entire webs every day, even if the current web seems perfectly fine. I wish I was this dedicated to maintaining my bedroom. These spiders actually do this because they want to be prepared for the evening when they patiently wait for their potential prey to get caught in their carefully set trap. At first, this might seem like a waste of time. After all, they need to invest a significant amount of protein to produce the silk that forms their webs. But even if an orb weaver spider doesn't catch its meal overnight, it usually has enough silk proteins to dismantle its old web and build a new one for the following night. As the spider removes the old web, it consumes the silk at the same time, and by doing that, recycles the proteins it contains. If you've ever observed a spider on its web, you must have noticed how attentively it responds to even the slightest vibrations. It turns out that spider silk can be finely adjusted to different sound frequencies, unlike any other material. When a spider builds its web, it doesn't just spin the silk and leave it as it is. The spider actually makes adjustments to the silk by changing how tight or loose it is, and how different threads are connected. This way, it creates a web that can vibrate or make different kinds of sounds. The spider is like a musician tuning their guitar. This feather-legged lace weaver is called the garden center spider because it mostly enjoys humid greenhouse conditions, and it has a really cool way of catching insects. Instead of spinning sticky webs like other spiders, it uses electricity. It produces incredibly thin silk, almost at the nanoscale. And on its hind legs, this spider has special hairs that act like tiny combs. As the silk emerges from its body, the spider uses these hairs to comb and manipulate the silk. And here's where the magic happens. This process generates an electric charge. The threads of the silk are now crackling with electricity, so they come together to form little poofs that resemble fluffy balls of wool. These electrically charged poofs are a great way to trap innocent insects wandering around. When unsuspecting prey comes into contact with them, the electric charge causes the threads to cling to their bodies, making it almost impossible to get away. Female Darwin's bark spiders make gigantic webs that can stretch over rivers and lakes, which means they can reach over 80 feet across. It turns out such enormous webs are just a part of their genius plan to catch their prey. A super strong web that goes across the water like a bridge can capture large insects that gracefully fly above the water's surface, like dragonflies, and it's an impressive project that takes days to construct. These special lines go across the river and anchor the web firmly to each bank. There's no easy way out of this.